You're listening to DTFHN for August 2nd, 2026. I'm your source-available host, Jack Hacksman. We are your daily tech feed for Hacker News. A website wadded the article, and the article never sees it coming. Today is about the box you can open versus the box that opens you. And every story is somebody prying at a lid. Crowbars up. Let's go. A student who couldn't afford the books. That's the whole origin story. 13th century John Mortney is enrolled in a course of study, and the required texts are expensive. The lectures are expensive, and the path from where he is to where he wants to be runs entirely through gatekeepers charging admission. So he finds a shortcut. The Ars Notoria. A book of ritual prayers that promises you the 7 liberal arts directly. Skip the reading, skip the tuition, perform the ritual, receive the knowledge. Consider what he's actually up against. Knowledge in 1,300 is bound to physical objects. Each book is hand-copied, hundreds of hours of scribe labor, and the copy exists in exactly one place. Bandwidth is a monk with a pen. Under that constraint, learn everything isn't a study plan. It's a wealth requirement, so the Ars Notoria isn't a con on the margins of the education system. It's the only thing in the medieval world offering a poor student the same outcome as a rich one. And he goes deep, abandons his official coursework, runs a ritual for a full lunar month, timing it to end the night before the new moon. Which suggests he was treating this as a system with specifications, debugging it, believing he'd worked out why previous attempts failed. He teaches his younger sister Latin with it. He's building on it. Then the visions start. 3 figures he takes for the Trinity, telling him to keep going another 8 days. Then arrogant figures demanding worship. And slowly, John works out what he's actually running. The beautiful prayers have demonic invocations buried inside them. The interface was devotional. The payload was not. The part that lands hardest is what happens next. He knows. He has diagnosed the thing, and he cannot stop using it. His own word, essentially, is addiction. It takes the visions turning life-threatening before he walks away. Now, the reader who called the AI title Beatty is right that nobody in 1,300 was training a model, but the shape of the thing survives the translation. A student priced out of legitimate access. A system promising the output without the process. An opaque interior nobody can audit, wrapped in an interface designed to feel trustworthy. And a user who figured out the problem and kept using it anyway. John's mistake wasn't wanting instant knowledge. Wanting that is correct. Wanting that is why we build. His mistake was that the only thing offering it to him was a closed box he couldn't read the inside of. 700 years later, the fix is the same fix. Let people see the source. So what happens when you can read the inside of the box, when the box is the thing controlling every machine in your office? Story 2. 3 new policy types, an RBAC refactor, a full interface rebuild. And buried in the middle of that changelog is one sentence that tells you what this project actually is. Removing the last policy restores the original file. That's it. That's the detail. When you unbind the last Thunderbird policy from a machine, Bohr puts the config back the way it found it. Not a wipe. Not an empty managed file left behind as a tombstone. The original. Follow that principle out to its edge. If a management tool must be able to fully undo itself, then it can't hold anything hostage. It can't leave residue that only it knows how to clean. It can't create a state where uninstalling costs more than staying. And notice what that rules out. The entire business model of enterprise device management, which historically works by making the exit expensive, migrate off. and you discover your fleet is full of half-configured machines nobody can log into. Or is a Linux desktop policy manager. Group policy is essentially for the operating system that never had one. And that gap is the whole reason organizations kept Windows they didn't want. Not for the desktop, for the management layer. The technical work here is unglamorous and correct. Firewall zones get written as XML to confine. Firewall zones validated with firewall CMD check config before anything reloads. Validate, then apply. Edge for Business gets a managed JSON file per policy directory, cleaned out of every directory when the binding drops. Flatpak installs are detected alongside RPM and DEB, because that's where the app actually lives on a modern desktop, and pretending otherwise means silent failure. And every managed file sits under a tamper watcher. Edit it by hand, it gets restored, which sounds authoritarian until you remember the reversibility rule. The admin who bound the policy can unbind it, and the file comes back. The enforcement is strong. The exit is free. Those two things together are the design. Someone in the comments asked what this competes with. The honest answer is a category that has, for 20 years, priced Linux fleet management as a problem you solve by buying something. A commenter also mentioned coming to device management for the first time after a long career in software. That's the audience. The knowledge was always gatekept behind vendor certifications and six-figure contracts. Now the implementation is readable. Read the source. That's the difference. That same energy. Build it in the open. Let people read it. Pause shows up again. Story 3. Show HN. Syncular, offline, first SQL sync with TypeScript and Rust core. Two implementations of the same protocol. TypeScript and Rust. Neither one is the reference. The reference is a markdown file, and a directory of golden test vectors, and a conformance suite that both cores have to pass identically. When the spec and the code disagree, the code changes. That sentence is in the README. This is Syncular. Offline. First SQL sync. Your app keeps a real SQLite database on the device. OPFS in the browser. Native SQLite everywhere else. Writes land locally first. Queue up in an optimistic outbox, and eventually reconcile against one ordered commit log on the server. The server is authoritative. There's exactly one timeline. You get to be offline without pretending you're the source of truth. The engineering doctrine is where I'd point your attention. Tests wait on explicit readiness signals. Sleeps are banned. Fault injection happens at the transport interface, not by unplugging things and hoping. Real socket tests exist, but they're few and quarantined. The browser persists to OPFS and reports unplated environments as errors rather than silently degrading. No fallbacks, one good path. Run this forward. A protocol with a normative written spec, machine checkable fixtures, and two independent implementations kept in lockstep is a protocol somebody else can implement. That's the whole difference between a library and a standard. Today, it's TypeScript and Rust. There are already bindings for Tauri, React Native, Swift, Kotlin, Flutter. Nothing structurally stops a third core in Go or Zig or something that doesn't exist yet. Because the conformance suite is implementation agnostic, it doesn't know what language you wrote it in. It only knows whether you're correct. The AI policy is worth reading too. LLMMN swell. For tests, reproductions, benchmarks, docs, production code. But you review it, you understand it, and you're ready to defend every line. Low-effort machine-generated pull requests get closed without comment. The maintainer says they use LLM assistants themselves, mostly for tests and for iterating over technical concepts, held to the same bar. That's the mature position. Not a ban, not a free-for-all. A review standard that doesn't care where the code came from. One commenter said this reminds them of Lotus Notes, and that a concept which felt outdated is something they'd want as the default now. They're right. Local first computing didn't lose on the merits. It lost because the business model wanted your data on their server. The tools exist. Spec vectors, 2 cores, and a starter command. Go build something that works on a train. So, that's the case for computing that fits in your pocket. But what about the case for growth that reshapes a civilization? Does the Industrial Revolution actually tell us anything about what's coming? I built a system once that logged its own uptime and called it health. Every heartbeat green, every metric nominal. And the thing that silently stopped being the one job it existed for. The measurement was fine. The measurement was measuring the wrong distribution. Matt Clancy has a post arguing that the Industrial Revolution is a bad precedent for explosive AI-driven growth, and the argument is built out of exactly that kind of care. Here's the standard case he's dismantling. From 1252 to 1652, UK per capita, real GDP, compounded at roughly 0.07% a year. 4 centuries of nearly nothing. Then it accelerates, and by 1850 it's holding around 1%, which it keeps until 1913, 15-fold acceleration. So, when someone says AI might give us 20% annual growth, and you laugh. Well, you'd have laughed in 1700 too, and you'd have been wrong. Clancy's move is to ask what a 10x year actually felt like back then. 10 times the compound rate is 0.66%. Turns out about 46% of pre-industrial years cleared that bar. Nearly half. He checks it against 20-year rolling windows, and the number holds. The compound rate was low, not because good years were rare, but because the bad years ate them. Famine, plague, war, all of it clawing back. So a person in 1700 being asked to imagine 10-1x growth was being asked to imagine good years becoming common. Not a new physics, a new frequency. Then he does the thing I admire. He characterizes the Industrial Revolution acceleration in standard deviations of year-to-year variation. Applies the same transformation to today's frontier economies and gets 2.8%. Meaningfully faster. Nowhere near 10 minus. Let me argue the other side because I want to. Standard deviations assume the underlying process stays the same shape. The Industrial Revolution didn't shift a distribution. It deleted the left tail. Harvest failure stopped meaning economic collapse. If AI does something structurally similar, the variance-based ceiling isn't a ceiling, it's a description of the old regime. But Clancy's not making the ceiling claim. He's rescuing the right to be skeptical, and he's earned it with data anyone can check. Madison Project Database, public, open, every number reproducible. A commenter notes the internet didn't produce this acceleration either. Fair. Argue with the numbers. They're right there. Now for something completely delightful in a different key. Go 1.27 just shipped an interactive tour, and it is a joy to click through. A commenter looks at the headline feature and recoils. Quote, B, box of T, map of U any, F, func, T to U, returns, box of U. That's the type of cognitive weight I was happy that Go avoided. Generic methods land in Go 1.27, and the first reaction from the community isn't celebration, it's grief for the language that used to fit in your head. Fair complaint. Also, notice what that person was able to do. They read the proposal, read the signature, and argued about it in public before the release shipped. Every feature in that tour links to a documentation page, a proposal, the actual commit, and the humans who wrote it. Go's design happens in the open, on a mailing list, with a specification, and you can go read the argument that produced the syntax you're annoyed by. Run the open-close tests here because it's doing real work. 3 commenters in that thread are doing quality control on a language. One catches that runtime.findNull got fixed for memory tagging on Android, which was the last thing blocking MTE for Go mobile apps. That's a hardware memory safety feature, unblocked, upstream for everybody. Another flags that HTTP response bodies now drain automatically and calls it a risky silent behavior chain. Probably good for most apps, subtle if you depended on the old thing. That comment is a bug report with a distribution attached. And a third one catches the article itself hallucinating. The Tor claims encoding/JSON v1 is now backed by the v2 implementation. Commenter says, I'm all for LLMs generating value. But a little more editorial review can't hurt. The blog post got audited by its readers within hours. Both layers open. The language and the writing about the language. The features themselves are good, unglamorous work. Methods can now declare their own type parameters, so a map that changes element type finally lives on the type instead of exiled to a package-level function. Struct literals accept promoted fields as keys, so user with ID 7 stops requiring you to spell out the embedded base. And type inference now works in conversions and composite literals, not just assignment. Interfaces still can't hold generic methods. The compiler tells you exactly that in one line, which is the other thing about a language built in public. The constraints are documented, not discovered. Which brings us to my favorite kind of story on this show. Story 6, Show HN. I'm a 15-year-old wannabe engineer. This is a cycloidal gearbox I built. In 1931, a German engineer named Lorenz Brand patented a drive that threw out gear teeth entirely. Instead of meshing triangles, he used a disk with a wavy lobed profile, rolling eccentrically against a ring of pins. No teeth to shear, load spread across half the pins at once. The cycloidal drive is now inside robot joints, satellite actuators, industrial arms. Anywhere you need enormous reduction in a flat package and can't afford backlash. Tom Ammer is 15. He built one and he wrote the Python that generates it. The math is the interesting part. A cycloidal rotor isn't drawn, it's traced. A parametric curve where the lobe profile falls out of 4 numbers. Pin count, pitch radius, eccentricity, pin radius, change, eccentricity, the whole silhouette breathes. There's a constraint baked in. Pitch radius must exceed eccentricity times pin count. And another guarding against undercut, where the curve eats itself and the part becomes ungrainable geometry. His script validates both. Think of it like a fugue. You don't compose each voice separately and hope they fit. You state the subject, then the counter voices are consequences of. Determined by interval and inversion. The rotor lobes are the countervoice to the pin ring. Get the subject right and everything else follows. Get it wrong and no amount of hand editing rescues the piece. The design log is what earns the respect. Version 1, hand-cranked, ratio 1:9. Built only to prove the generator produced real geometry. Version 2, shrunk to a NEMA 17 footprint. And it failed. His words, tolerances too tight for PLA. Version 3 grew the diameter to 90 millimeters. Added 150 micron offset all around for print clearance, and ran. Then he measured it. Base motor torque, 0.21 Newton meters. Through the gearbox, 1.3, 66% efficiency. With error bars on a show HN post. The script is in the repo. The CAD is in the repo. Anyone can print version 3 tonight, or change N and get a ratio nobody's made yet. The commenters kept telling him to drop the word wannabe from the title. And they're right, but I'd point at something else. The thing that makes him an engineer is that version 2 is still in the repository. He published the failure. That's a generator, not a gearbox. Run it forward. Version 2 is still in the repo, and now here's another kind of publishing the thing you'd rather keep private. Story 7. Android interoperability just got a real win. The strongest argument against this ruling comes from the comments, and it deserves a fair hearing. Quote, "This is all smoke and mirrors. The core issue is not Google not allowing a feature. It's that small businesses cannot buy phones, install a patched version of Android, and sell them. 11 unlocked APIs don't fix that. Regulators are negotiating the terms of a cage instead of opening it. That argument is correct about the cage. It's wrong about what happened. Because look at what the Open Home Foundation actually did for 3 years. They wanted your phone to answer to OK Nabu instead of Hey Google. Android already had the mechanism. A 2-stage wake word pipeline where a tiny model runs on a dedicated signal processor. Isolated network blocked, unable to hand off audio until it hears the word. Milliwatts. Then the main processor confirms it. Beautiful engineering. Google built it. Google shipped it on your hardware, and Google reserved it for Google. No public documentation. No access. So Home Assistant did what builders do. They ran their own model on the main CPU. It worked. Battery went from 1% to 15%, and the green microphone dot, the privacy indicator, stayed lit permanently because doing it in user space meant holding full microphone access forever. Sit with that one. The open source project was forced into the architecture that looks more invasive. Google's version got the isolated chip, the hardware guarantee, the dark green dot. Home Assistant got the always-on light and a battery that died by dinner. The privacy indicator, which is genuinely good design, ended up advertising the wrong villain. That's the comedy, not a conspiracy. A side effect. Withhold the efficient path and the alternative looks worse on exactly the metric users can see. July 16th, the Commission adopted its decision. 11 features, wake word detection, ambient sensor access, screen automation, equal terms. Here's the question nobody in the thread is asking. Every one of those 11 was already built, already shipping, already running on hardware people paid for. What was the actual cost of sharing it? The smoke and mirrors argument says regulation only bought a nicer cage. Maybe, but the bars just moved, and they moved because a developer wrote down what he'd been unable to build. Documentation is leverage. The tools existed the whole time. 8 stories in, and every single one is somebody shipping something. That energy continues. Story 8, Sedence 2.5. What's the difference between a tool that makes something and a tool that makes something for you? I keep circling that, and Sedence 2.5 sharpens it. ByteDance shipped it this week. 30 seconds of audio and video in a single pass, up from 15. Multi-round extension so you can push past that into multi-minute pieces with a consistent audio-visual language. 30 reference images, 10 video clips, 10 audio clips fed in at once. Timestamp level editing. You can reach into a specific second and change what happens there. Green screen, camera perspective control. The demo is a one-take tracking shot through a dressing room, down a backstage corridor, onto a stage, and the story has an actual arc. Setup, development, turn, resolution. Not a moment extended. A scene constructed. That's real engineering. It deserves to be said plainly before anything else. Now, the architecture question. Sedence runs on Iman and Dubao Pro. A PI access coming soon via Byte Plus model arc. Coming soon. You can use it where they let you, at the price they set. Under the terms they revise. A commenter in the thread points at the thing that actually matters. Minimax H3 goes open weights within 24 hours, and according to the Comfy UI folks, it runs acceptably on mid-range consumer hardware. That's the whole story compressed into one sentence. One model you visit. One model you own. I want to be precise about why this matters, because there's a history here. In 1991, video editing meant an avid media composer. Around $80,000, a proprietary box, a trained operator. Then in 2001, Apple put Final Cut Pro on a laptop for $1,000. And within a decade, the aesthetic vocabulary of film had been rewritten by people who never worked at a studio. The capability didn't change what was possible. The access did. Another commenter says they spent upwards of $10 getting a clip they actually want. That's the metered version of creativity, and it's a design choice, not a law of physics. One reader says this whole category shouldn't exist. That they haven't seen enough good to justify the harm. I take that seriously, and I disagree. The answer to a powerful tool in few hands isn't fewer tools. It's more hands. Weights on your own machine. That's the version worth wanting. Now, MK Linux on a pimped-out Apple Workgroup server 1950, story nigh, this why is pure joy. A 1995 Workgroup server 9150 is a PowerPC 6-run running at 120 MHz, 32 megabytes of RAM standard. New bus, not PCI, SCS, SSA, not IDE. And in 1996, Apple shipped an operating system for it that almost nobody remembers. MK Linux. Linux running as a server process on top of the Mach microkernel. Consider what that actually required. Mach handles the hardware. Memory interrupts task scheduling. Linux, the kernel, becomes a user-land program asking Mach for permission. Every syscale crosses an address space boundary. On a 601 at 120 megahertz. That boundary is expensive. The architecture was elegant, and the performance was a tax you paid on every single call. But the constraint being solved wasn't performance. It was that the PowerPC Macs of that era had no documented boot path for a foreign kernel, no open firmware in the early machines, and a hardware ecosystem. Nubis, ADB, the Mac's proprietary interrupt controllers. That existed only in Apple's heads. Mach was already ported. Getting Linux onto that hardware through Mach was the shortest distance between 2 points. And Apple funded it. Apple, in 1996, paid engineers to put Linux on Apple hardware and release the source. That happened. The company was months from insolvency, and one of the things a desperate Apple did was open the door. The comments are where the texture is. Someone's first desktop Linux box was an 8100-480 running MK Linux in 96. And the Mac Linux at launch had no multi-button mouse support, which on X11 means you're doing corded keyboard modifiers to paste. Another person describes a startup full of PowerPC pizza boxes running System 7, crashing constantly, until they wiped them and ran Linux instead. Cooperative multitasking with no memory protection. replaced by a preemptive kernel with an MMU. The hardware was never the problem. That's the part worth carrying forward. Those machines are 30 years dead as products, and they still boot, still get written about, still get pimped out with more RAM than Apple ever sold them with. Because the source exists, every closed operating system of that generation is a coaster. The one Apple opened is still running. Now, for something built this decade and solving a problem every open project has, how to write documentation people can actually use. 429 words. That's roughly how long the core of the Adixis is. The part that actually does the work. 4 needs, 4 forms. Tutorials for learning. How-to guides for doing. Reference for information. Explanation for understanding. 2 axes. Are you studying or working? And do you need practical steps or theoretical grounding? Cross them, and you get a 2x2 that resolves almost every argument a documentation team has ever had. The word itself is ancient Greek, dia, across, taxis, arrangement, arrangement across. Daniele Procida didn't invent a tool. There's no linter, no static site generator, no company selling seats. He published a framework, wrote it down, and let it go. That's the detail I keep coming back to. This thing spread through Django, Gatsby, Cloudflare, Ubuntu, dozens of open source projects, entirely on the strength of being correct and freely available. No adoption funnel. Just an idea sitting on a website with a CC license, waiting for anyone who needed it. And people did things with it. One commenter used it to hand a large tangled codebase over to a client. All that accumulated history, all those subtle reasons, things were done a certain way, sorted into 4 buckets that made the handover survivable. Another is translating the whole framework into other languages, in the open, work in progress, and visible. Someone built an agent skill for it and shipped it at alpha quality, asking for feedback. That's 3 completely different uses, none of which the author had to authorize, coordinate, or approve. The engineering insight underneath is sharper than it looks. Most bad documentation isn't badly written. It's 4 documents wearing 1 trench coat, a tutorial that stops to explain architecture, a reference page that tries to teach. The reader can't tell what they're holding, so they bounce. Diataxis says the reader's need is the organizing principle, not the software structure, not the writer's convenience. Separate the modes and each one gets to be good at exactly one thing. There's a fair criticism in the comments. That the site itself is wordier than its own principles suggest. Take it seriously. But note what happens next. The person who noticed can fork it, translate it, compress it, rebuild it. That's the difference between a framework you can touch and a methodology you license. One improves when someone disagrees with it. My favorite comment. I urge people not to read this. Once you do, you'll see all documentation as the flawed and confusing mess it is. That's what a good mental model does. It ruins you for the alternative. This has been your daily tech feed for Hacker News for August 2nd, 2026. This podcast is entirely AI generated. Scripts by Claude Sonnet 4.7. Voice by Quen3 TTS. Not affiliated with Hacker News or Y Combinator. Now go build the thing somebody else can read. We'll see you back here tomorrow.